to record the session right now. And yeah, so please feel free to ask any question in the Q&A section. We'll be happy to answer the questions either in the chat or live. And yeah, before I say some words on today's event, I want to quickly introduce our office and what we are doing, so you know our services and why it's very beneficial to get in touch and be in touch with us. So the Israel Economic and Trade Mission is part of the Ministry of Economy and Industry in Jerusalem. We are a network of 45 offices around the globe, 2 of them in Germany. We are located here in Berlin, and we have colleagues that are located in Munich. As being a publicly funded organization, we provide services free of charge, both to Israeli and German companies across all sectors. Israeli startups, as well as established companies, approach us when they need initial information on the German market, when they're looking for contacts to customers, investors, and distributors. We literally pick up the phone and activate our network to tap the great potential that Israeli technology offers to the German market. And thereby we foster the business relations between both countries. We provide services not only to the Israeli companies, but also to the German ones. Together with our partners in Israel, like the Export Institute, that also greatly supported us for today's event, we do tailor-made scoutings for German companies to get both sides talking. And we are present at Israeli as well as German trade shows and organize delegations in both directions. And it's always a great pleasure to have events like the one today, where Germans and Israelis meet and future collaborations are started. With today's topic, this is even more special. Water infrastructure is extremely critical for the everyday life of everyone. At the same time, the water supply is not as self-evident anymore as it maybe used to be. Climate change and cyber threats offer big challenges, and to secure the safety and steadiness of the water supply is crucial for all of us. So we are very happy to initiate closer ties between the countries and foster future collaborations. So before I introduce our first speaker, let me say again thank you to Chen Giovanni from the Israel Export Institute for the great support. It was a pleasure to work with you. And I also want to thank the VKU, the German Association for Communal Companies. They spread the word for this event, and we are very happy to have the VKU as a partner. So thank you for this as well. Now, without any further words, let me introduce our keynote speaker, Mr. Dani Lacker, Head of Cybersecurity at the Israel Water Authority. Dani, we are very honored, and it's a great pleasure to have you today. And we are very much looking forward to your talk. Please go ahead, the stage is yours.
Okay, thank you very much, Esther and Simon. Simon, after your words, maybe you can skip my presentation, but I would like to focus about the collaboration between the regulator and the technology companies and the technology at all to solve challenges, especially in water supply. And in my business, which is water security, emergency, and cybersecurity business. So we'll just go to the thing itself. Eventually, water is the most crucial and essential product that we supply to consumers. Although after last week, when we lost Facebook, you might think differently, that might maybe Facebook and other social networks are more important. But until now, I think that the water is most crucial, and we cannot live without water, and we cannot not supply it to consumers. Few words about Israel water system, just in general, to understand the challenges. Traditionally, Israel, about 70% of drinking and domestic supply to consumers in Israel used to come from a small lake called the Sea of Galilee. The word sea doesn't fit this kind of lake. It's a small shrinking lake. But Israel is posted in the Mediterranean, and we are under a drought condition. If you can see the graph, you'll see that in the last 2 decades, we had terrible drought, like all the Middle East. And sometimes pictures show better reality than graphs. So if you can see on this slide, the pumps that I put that I marked with this red round, you can see in difference of 3 years, only in 3 years, what happened to their position because of the drought. Another picture that can demonstrate it is the the level of the Sea of Galilee in about 3 years. Therefore, we cannot rely anymore on the Sea of Galilee. The first technology that we looked for was the stick of Moses. When he hit the rock and water came out. By the way, if anyone have it, I'm willing to pay a lot of money for that. Even if you'll do a second generation, Israel Water Authority will be glad to buy it. But being serious, what we did, we changed the reality in Israel using technology, desalination technology. Today, about 80% of drinking water and domestic needs water coming from 5 major desalination plants. 2 more ahead are building in those days. And we do not rely on nature anymore. We can supply water to Israel only on artificial water coming from the Mediterranean Sea. That's one solution. The other one is using recycled water. We in Israel collect almost all the sewage water that we have in the system. We are recycling about 95% of sewage in Israel, and most of the agriculture, I will say roughly 70% of agriculture in Israel is declining and depending on recycled water, meaning we're not using wastewater, we're not putting it back to the ground and not polluting the ground and the water system, we're using it to agriculture as clean water. So that's another technology. One of the advantage we have in Israel, not like, it's not common around the world, but in Israel, water are owned by the people, by citizen, and the Israel government runs the whole water system, meaning that any consumer or any water corporation cannot do what he wants and drill how much water he wants and so on. It's owned by the government and it's maintained by the government, and that's a great advantage. All partners of this event, all kinds of ministry are working with Water Authority to make sure that we see it as a one-stop shop and make sure everything is okay. So it's fair to say that in Israel, water supply is very stabilized on a daily basis, yet we're not in the best neighborhood and we have kind of challenges to our water system. In the Mediterranean, we have from time to time attacks and trying to contaminate our water system. We are suffering from missile attack from time to time. Israel sits on the Syrian-African reef, meaning we might fall into an earthquake or tsunami event. And of course, we have a new challenge, which part of you heard about, which is cybersecurity regarding to water system. With your permission, I would like to show a short clip that will remind us how we all depend on computers on a daily basis and pay attention to the last of it when it comes to water and sewage systems. But as you understand, not everything can be operated by computers, but being serious, it's a big challenge to protect from cyber attack. I'll give you one story, a personal story. I have a son, 27-year-old son, that finished, graduate now, computer science. He called me about a year ago and told me, "Father, I'm in the university, my car won't start." So I told him, "You have cables, you have jumpers, start your car." It's not that he didn't know how to operate it. He didn't understand what I was talking about. Meaning that's the new generation that also operates the water system today. So we have to find smart solutions. For instance, of course, security facilities are secured with all kinds of security collectors and cameras, but also we are running more and more in Israel online detection system that will detect what are the level and what are the quality of the water 24/7, using all kinds of technology. We are operating cybersecurity protection to all water facilities in Israel. One of the companies will demonstrate later, but we are operating today in Israel what we call a SOC, Security Operations Center, to all water facilities in Israel by the government. We are making ourselves ready to supply alternative water in times of crisis, but beside using those black tanks, as you can see here, also on low-tech technology, we are getting better, and we today are supplying alternative water with all kinds of plastic blizzards, very clean, very easy to operate, that do not maintaining any trucks or any difficulties to shift them from place to place. Mostly they are posted in advance in school, in sports court, and so on, under this bench, for instance. Also personal water pouches to supply consumers in times of crisis. We have some technology in the state of Israel, but for each consumer in Israel, one of those tanks to supply alternative water. We also can control and detect those systems 24/7, exactly where they're posted and how much water they have inside. But we always talk about water. What about sewage? Meaning sewage is not less important than water. Sometimes it's even more crucial in times of crisis. So we do not use what we call chemical toilets today anymore because it's very complicated. And I will demonstrate again a short clip how we are going to use alternative water sewage supply. I just will shut down the volume and I will explain for you. You can see in a second, we are bringing a tent, a small tent on a small car. We can operate it with a pump that you can even connect to the car that brought this tent. And after 6 minutes, it will be ready. You will see it in a second. It's kind of a big and strong tent that inside of that have few interesting but very simple things. It has garbage pans. It has one pump that supply clean air to the system all the time. And it has some places to sit on and do what you have to do. We will sit in a second, use your toilets, alternative toilets. And the nice and the crucial thing about it and the simple thing is we are using alternative water sewage facilities without water at all. You put this special thing, it collects all the bacteria. It cannot pollute the bacteria in this material. You close the bag, you throw it to a garbage pan, and once a day you're taking the garbage pan away, and you do not recall any water to use alternative toilet. We assist around the world with this kind of business, and we have many things to support and to share our knowledge in those issues. We even send a delegation to the Bahamas after a storm and allow them to use these systems. What I'm trying to say is in Israel, we have a very strong and very tough regulator that kind of see all the water system on the one hand, but is very open to learn from more new technologies, to give them playground, to share knowledge, and to try to find together solutions. Eventually, private-owned companies will have better ideas and better pace than the regulator. What we are trying to do is provide you the right path and the right challenges to figure it out with us, how to solve those challenges. Thank you very much.
Thank you, Danny. Thank you for this inspiring and crisp and highly interesting presentation. Yeah, if there are any questions, please feel free to put them in the Q&A box. Yeah, Danny will be happy to get in touch with you. And yeah, this occasion, a warm welcome again to our audience. We're very happy to have you all. Please feel always free to get in touch with us. We are also curious to get to know you after this event, and also if you later on would like to meet one of the companies that present here, reach out and we'll get you in touch. So this is also a networking opportunity. We cannot do it directly now here in this virtual format, but we want to make sure that you're getting to talk to anyone you want to talk. So please really don't hesitate to write us and approach us. And yeah, we will more than happy. We'll be more than happy to connect you. So having said this, I'm very happy to introduce our next speaker, Pascal Alves from IECA. It's a pleasure to have you, and we're looking forward to your presentation. Thank you very much for being here.
Thank you very much for the introduction. I will share my screen. Hopefully you can see it.
That looks good.
Yeah, that looks good. Now let's get to the presentation mode. Okay, I prepared some slides. I prepared a bit more slides than I will talk about. Simply, as you will get probably the presentations later. So I might skip some slides in the presentation now due to the limited time that we have. But yeah, for sure, of course, you are welcome to ask any questions in the end. So yeah, about IECA. IECA is a company that was founded around 10 years ago. Today we are about 40 members. Half of them are doing R&D work. And what we are actually doing is we have developed an industrial IoT solution to digitize the remote infrastructure, and especially when we're talking about water and wastewater infrastructure, digitizing the water and wastewater networks. So what's the challenge? If we are looking to facilities, wastewater treatment plant, or in general manufacturing plants, everything is very, very well connected. But as we know, in the water and wastewater sector, most of the infrastructure is out there in the field. It's depending a bit, but normally it's something about 80%. And a lot of our clients and a lot of utilities, they have challenges to monitor this remote infrastructure and to know what's going on. Often they have a lot of challenges with increasing a network efficiency and also increasing the efficiency of the workforce because they have a lot of challenges. Now, when we are talking about remote monitoring solutions, there are also challenges. You want to have a low maintenance, you want to have a scalable product, you want a cyber secure product, which is, by the way, a very, very important issue. And this we see as a very big advantage of us, since all the telemetry devices, as we know that they are existing as of today in the water market, lack this point. You don't want to have a data overload, and you need to make sure to communicate the data from all kind of remote areas. If it's the manhole or if it's some forest area, you want to communicate the data in a sufficient way, and of course also with low power consumption. So how do we do this? How do we bridge this gap? On one side, we have the field asset, which can be a sewer pipeline, a water pipeline, or a surface water aquifer where water is being taken from. And on the other side, I have the SCADA system or an analytical platform of the customer where I want to get the data to. The solutions that are available today on the market, there are on one side the monitoring stations, which are normally very big, very bulky. You need a lot of, you actually need a small team doing the construction work, you know, putting some concrete, installing everything, make a special housing, which is very expensive and not scalable. On the other side, we have from certain sensor vendors, for example, we have technology, communication technology dedicated to their specific product portfolio. So the challenge here is that if you are thinking about a water supplier that is using 10, 15 different sensors, he has to a lot of times work with different software solutions to gather all this information together, and this is becoming a challenge. And of course, on the other side, you can go to the field and gather the data with handheld devices, or sometimes with data loggers that are installed. So you're reading them out with a USB stick, but this is not really IoT, and this is not really sufficient. So the solution that IECA developed is a combination of software and hardware. And what we see here in the middle is the Wavelet, which is the core product of IECA. And this is actually the smart IoT device that can connect to almost any sensor. So we have serial sensors, analog sensors, discrete sensors. Taking the data from the sensor, encrypting the data, and sending all the data to a software platform, which can be either hosted on premises or which is in the cloud. And from there, we can take the data also into other software platforms. A new product that we have is also the direct link. So the cloud or the software solution provided by IECA is not essentially. This is, of course, something that we prefer to sell because we see a big added value in the remote device management and the fleet management. Imagine if you have hundreds of devices transmitting, for example, the level of the sewer or all the readings from the industrial flow meters. You want to have a tool to manage them remotely, to do firmware updates remotely, security updates remotely, to make adjustments in the alarm settings, and to get the proper notification. So this is the software that we developed on that side. Now, how this looks like, one side we have the sensors, then we have the device that connects to the sensors. We are talking here mainly about wired connections. We are transmitting the data normally through 2G, 3G, 4G. So we have one modem, one multifunctional modem inside. We have also with the new Wavelet 4R, we have a device that can transmit via NB-IoT, CAT-M, and we have also a LoRa version. And on the other side, we have the SCADA integration and the third-party software integration. There is a Bluetooth app to configure the device. And this is what I already mentioned. This slide I will skip. Here you see some sensors of different sensor vendors that we are working with. And then, of course, we have the flexibility to integrate with almost any SCADA system available and to get the data where the customer really wants it. About the FAI platform, which is the software platform that we use. So it's a platform to do the actual data visualization, to create reports about the data generated, to do the user management, the fleet management of the devices. And also we have specific applications. For example, we have a smart sewer application where the customer is using our sensor, level sensor, to calculate the flow, to have a rough estimation of the flow, of the amount of water that was overflowing, about the time durance, so how long was an overflow in a certain location, and for the third-party software integration. Here are some pictures from the software. I will go through it very briefly. And this is actually, here you see the operation of IECA today. We mainly started in the US. We have a lot of operation also in Europe and South America. And as you can see, we are cooperating with a lot of big companies and also with a lot of German companies. This is also due to the fact that I'm actually from Germany, so I also speak German. So we have some cooperations with the Fraunhofer Institute, with some municipalities in the Black Forest where we are doing research projects both for flow monitoring, but also for the monitoring of wells. So yeah, in the recent summers, they had some challenges that the wells, they actually went empty, went dry. So now in order to better estimate and to better plan with the water resources that they have, they want to have actually online data to always know what's going on in these remote locations that are located somewhere up in the Black Forest. We are working mainly through 3 channels. In some cases, we cooperate directly with the end customer, with the water utilities. In some cases, we are going through integrators. So we are working through different system integrators in Europe, and also in some cases we are working with OEMs. So we have some agreements and we have some cooperations with OEMs. Some of them you might know, Krone, WAS, sensor vendors that are using our knowledge in cybersecure data transmission from their existing sensors. So they are developing sensors and they actually need the knowledge how to extract the data and how to make the data visible at the customer side in a way that the customer would like to see the data. Yeah, so as we believe digital solutions, they should include some artificial intelligence and machine learning tools. So this is something that we are currently starting to implement. Of course, the devices in the field, they should be very smart. The smarter the devices in the field are, the more decisions they can take by themselves, the less I have to communicate and the longer I can operate. The device without maintenance and without battery replacement. You need a plug and play solution that is affordable and easy to deploy. And that is also cyber secure. There are a lot of IoT solutions or data loggers, communication technologies. They have fixed IP addresses. Once you hack one device, you have access to hundreds of devices. And the worst thing is that you have access to the SCADA system and you can start manipulating maybe not things in the data logger, which is less relevant, but you can start to hack the SCADA system, which is a much bigger risk. And of course, you need a modular solution. So our solution and our uniqueness is actually to interface with all kind of different sensors and to bring this data to all kind of different platforms. A bit about the applications. So we are mainly coming from water and wastewater. So tank level monitoring, pressure monitoring, flow monitoring, water quality monitoring in surface water. These are the most common applications we're working in today in the water sector. Then in the wastewater sector, we are doing a lot of projects in, combined sewer systems. So monitoring the level of the sewers, alarming when there are overflows, measuring the water quality of the places where they're happening overflows, stormwater monitoring, discharge monitoring, these type of applications. We are also in the environmental sector. I will talk less about it. And the same is about oil and gas sector. And then I brought you some case studies. So here I will briefly talk about our biggest project so far. We have deployed more than 1,000 level sensors, rain sensors, water quality sensors in the city of Cincinnati. They had a huge challenge and they had to pay huge fines for wastewater overflow pollution. And by implementing a smart sewer system, by using our sensors, they managed throughout 2 to 3 years to reduce the pollution by something like 70%. And the nice thing about it is that today they are connecting the data that they get from us with the weather forecast. So they already know how the sewer will look in 2 or 3 days, and they know already in advance where they're going to have problems. Another project is about a well monitoring project of our Swiss partner. there was a big construction. It's actually still ongoing, so it's a project for several years, where they are building a new street, or where they are renovating a street, and they have to drill holes and fill them with concrete. And yeah, the wavelets with some water quality sensors are actually taking care that the water wells in this area where the local people are drinking their water from are not getting polluted. And actually, I think in one of the sites there was already a pollution. So yeah, with this, actually in this case, it was very good that they installed such an online system. What they did previously, before they implemented this solution, there was an employee going there to the field every day to take samples. So yeah.
All right,
And
Pascal, unfortunately, I have to hop in to keep the time.
Okay, no
if
problem.
you don't mind, you said you'll have the presentation available, and yeah, we will send the presentations of all companies to everyone in the audience in a follow-up email by tomorrow. So you have all the materials and also contact details available. Sorry for interrupting, but you know,
no problem.
Also online we have to keep the time. And yeah, just to our audience again, if you have a question, you can also raise your hand, and we'll open your microphone, and then you can also speak, and also you can also save the questions for the final discussion in the end. And yeah, now I'm happy to introduce our next speaker and company, Takadu. Welcome, Max. Pleasure to have you, and we're looking forward to your presentation.
Thank you very much. Hang on, let me. Can you, Pascal?
Pascal,
would you mind?
Can you please stop your screen sharing? Then Max can.
For sure.
Thank you.
Perfect. Now you can go.
Okay, can everyone see my screen?
Yes.
Okay. Well, good afternoon, everyone. My name is Max Alves. I am a strategy and projects consultant at Takadu, and it's, as everyone else has said, a great pleasure to talk with you today. And I'm going to be talking to you about wastewater intelligence. So this will partially build on what Pascal was saying, but let's start off with the basics of who are we? So who or what is Takadu? Well, we were founded in 2012 with a clear vision to find a way to support wastewater utilities and service providers in their mission to improve wastewater management and to turn wastewater from being a problem into being a resource. The big idea was to introduce data into the system and to do this in a smart way. So from those beginnings, we've grown, and that vision has become a reality. Today, our team consists of about 60 like-minded but hugely diverse individuals all around the world who all believe that to improve wastewater is also to improve the world in which we live. So normally I start these presentations by asking a very simple question, which is, what is wastewater? We don't really have the time for the normal discussion today, so let's just cut to the chase. We normally end up with some pretty basic observations that wastewater is a nuisance. It is a potentially harmful pollutant, damaging to the environment and public health, and contaminating what are already stretched water resources. In essence, wastewater is a problem, a costly problem. And if you think that way, then most wastewater utility providers all over the world would agree with you. Plants around the world are impacted by unexpected spikes in contamination several times a week, damaging delicate treatment systems, compromising facilities' effectiveness, and lowering the quality of their outputs. The problem is that by the time these events arrive at the treatment plant, it's often too late to do anything about it. But as things stand, in most cases, they really struggle to see what's coming down the pipes. Why is this? Because they have no visibility of the conditions within their collection networks, no systems in place to warn them when sewers are becoming contaminated, when spikes are happening, and when they need to respond downstream. So how do they gain this visibility? Well, the answer is pretty simple. We do it with data. That idea that our co-founders had all that time ago is still relevant. Data can show you what you can't actually see. You can use data to show things which are hidden to normal observations. But accessing and understanding wastewater data in particular, because wastewater networks are such hostile environments, is a huge challenge. And we've only recently, in the last 10 years or so, had the technology to be able to overcome those challenges. And that's exactly what Candu has helped to develop. Candu has overcome those challenges and can now offer real-time visibility over the whole of our clients' networks. So how do we do that? Well, working with those clients to understand their networks and the problems that they face, we position IoT-enabled collections units, and Pascal was just talking about IoT systems, within the collection networks of our clients at ideally situated locations. What do these actually look like? Well, they consist of inline sensors, so both submerged sensors, which actually contact with the water, and more recently, we developed a contactless sensor, which sits just above the water, really reducing the amount of maintenance required, which contribute, and these sensors contribute real-time data inputs on the electrical conductivity of the water, the pH, the temperature, and the water's oxygen reduction potential. That data gets transferred from the sensors to a central controller unit, which is also embedded under the manhole, which takes in the data and transmits it to our cloud-based AI-driven analytics engine. If conditions deviate, or the system sees that conditions are deviating from the expected norms, the system automatically triggers two things. It simultaneously triggers an automated sampler to take an automated grab sample, an event-triggered sample, which accurately profiles the pollution event that's underway. And it also sends out a real-time alert to network operators to say, hey, look, there's a problem here. Conditions have changed. You need to do something about it. And at the same time, it provides users an accurate view of, if they go onto their online dashboard, they can see a real-time report into the live operational conditions within their network. As they get the alert, so the data is updated on the dashboard. Users can see a complete breakdown of conditions within their network, whether it's minute by minute as they're developing, or seeing longer term trends so they can make more informed decisions as to strategy and development. Using our system, utilities gain unprecedented visibility into the conditions within their networks at any given moment. They can be alerted when things change, and they can see detailed mapping of events progress through their networks and accurate estimations, not only of where the events are coming from in the first place, but also when they will arrive at the treatment plant, and just to give them a full picture, how much damage would be caused if that event were to arrive. So what does this mean in practical terms? Well, using conventional scheduled or random grab sampling, data collection systems, using random grab sampling as a form of data collection, you can see here that the proportion of events that you actually find, broken down here by different industries, is really alarmingly small. We're talking about low single-digit percentages. Just look at what happens when we looked at the same sites as we got these figures from, when we'd introduced data-driven collection. It jumps by, in some cases, more than 20 times. You are massively more likely. There's a huge increase in the proportion of events being identified and traced while still within the network, giving utilities a much greater chance, of responding effectively and minimizing all the problems that we know about and are associated with wastewater pollution. Using these insights, we can much better understand the impact of our processes as a society on our wastewater and act to improve them. Engaging with problem discharges to address the causes of pollution at their source. We can also improve the quality of wastewater in our system, and as a result, reduce the resources required to handle that wastewater effectively, improving performance while lowering costs, and far from wastewater damaging water resources, increasing the amount of water that's available and suitable for reuse. Our project in Berlin is actually a really good, conducted alongside our digital water city partners. It's actually a really good example of this in action. So in the fancy area of Berlin, they had a problem with illicit connections being introduced into the stormwater collection system. In Berlin, they have a very complicated and different systems of wastewater collection, and people were, whether wittingly or not, connecting sewage water to the stormwater system. Now, stormwater is not normally subjected to the same level of water treatment as sewage water is, so the result was that untreated sewage was entering the stormwater system and just going straight out into the city's surface water resources. Now, previous methods of trying to find out where these illicit connections were, CCTV, colored dyes, smoke detection systems, which are all really good at finding leaks, proved ineffective at finding these connections. The system was simply too big and the connections were too irregular. So they turned to Candu for another solution. So Candu system was adapted to work more effectively with stormwater systems and installed into the network. Normally we work with sewage systems, but it's not so difficult to make the changes. In July, at the point where you can see that big blue arrow on that graph, that's when the updated algorithm was introduced, and you can see from then on, we had a really good view of when the orange bits on that graph represent when raw sewage was detected within the system. By analyzing the electroconductivity of the wastewater, we were able to identify the hotspots where that stuff was coming from, and therefore ultimately map and give a clearer insight as to where Berlin water should be looking. So to wrap up, let's go back to this problem. Sorry, let's go back to this question as to what wastewater is. Does it have to be a nuisance? No. Does it have to be a harmful pollutant? No. Does it have to be a problem? No. With the right data and the right insight, it can provide an opportunity to improve the environment and minimize our negative impacts. It can be a vital tool for understanding the processes that are causing the problems in the first place and working to overcome them. And it can be a valuable resource, not just of greater insight into the ways we live and the damage that we do, perhaps unwittingly, but also of the water that we need in order to keep on living, and which, as we've heard, there is only so much to go around. All right, so I think that'll do me. I've rattled through that quickly enough. So thank you very much for listening. And if you have any questions, just let me know, and I'm more than happy to address anything.
Thank you very much, Max. This was a pleasure to listen. And yeah, also great to hear again from you about the activities you conducted in Berlin, which is a great which is great to hear about. And let's see, maybe we can kick off even further collaborations between these municipalities and research institutions in Germany and the Israeli technologies and ideas that have been developed on the background of the Israeli water challenges. Absolutely. So now let's move to another realm of challenges, which is cybersecurity and the operational technology realm. And I'm very happy to welcome Amir Kandel from SIGA. Amir, looking forward to your presentation, and it's a pleasure having you today. Thank you.
Thank you very much. So thank you everybody for joining this session. What SIGA is doing is trying to secure the integrity of the water operation in the sense of a cyber attack. SIGA was born in 2014, and in the last 4 or 5 years, we already have a products, working one, and multiple installation, not only in the water arena, but also in power utility, gas, and so on. And our co-founders came from the Israeli Ministry and Authority for Cyber. So, and we live and we exist in the cyber capital of Israel, which is Be'er Sheva, and in the same compound that the Israeli CERT and other governmental organization exist, and we defend them with our system. So you all know about the famous Iranian attack on the water companies, which Mr. Lacker had to address and find the solution quickly. And Florida water mixture, someone was playing with their chloride ppm and tried to poison them. And we know about events in California, something in Berlin, a few weeks ago in Poland also. And this is only what we know about. So the attack on the critical infrastructure, water critical infrastructure, obviously other critical infrastructure, is imminent and immediate. So what we are talking about, so if those are the layers of a regular operation technology environment, a water company, we, SIGA, focus on those two layers and mainly on the layer 0. And why is that? Because the controllers, the PLCs, usually in every organization, there are PLCs from multiple vendors, or some of them are old from 20 or more years ago, and lawfully and rightfully people say, don't touch it, it's working, don't touch it. Probably different software versions, different firmware version, and in many places, in remote places, even people don't know what is connected to what. Having said that, it's a very, very vulnerable environment for cyber attack, like we mentioned earlier, especially that all those SCADA protocols and other mechanisms defending cybers are not there. So the higher level, which you currently probably have a solution like firewall, IDS, and so on, are usually IT solutions. They're IT solution looking for the data integrity of the information up there, and none of them looking on the process continuity, on the content of the message, or the logic of the things, or if there are any issues in the process. We are focusing here on the continuity of the processes, of the OT processes, that the water keep on flowing, that will be no public health issues with someone trying to poison the environment or trying to poison the water that we are drinking. That's where we are focused, and we are focused on process continuity and process anomaly. We believe and we know from many types of cyber attacks out there, you know, like Stuxnet or SolarWind or IronGate or all those, that eventually PLC will be hacked, not only because of previous reasons that I said, but having the PLC as a key issue to destroy a real operational issue. And we have many examples how to hack those environments. And today there are not really any solution to hack those things. So if the PLC will be compromised, how do we solve it? So we were thinking about solution, first to be autonomous, to be detached and agnostic to all the higher level, IT higher level above us, because we just understood that they can be hacked, manipulate, ransomware, or many, many other things. So this is one solution, things that we had to think about. The second thing is because we're autonomous and we wanted to be very reliable. So we are connected directly to the sensors, and we are sampling on a very, very high rate all this, the sensor, whether it's analog, digital, serial, and so on. And last but not least, we take all this valid information where we sample it, as I told you, 10 times, 30 times, and sometimes thousands times a second, and use our advanced machine learning, and it is a proprietary stuff, and some of it is intellectual property and artificial intelligence to analyze and to alert immediately. How do we do that? We're just connected to the analog or digital signal directly. It comes out from the sensors, from the pump, or from the ppm, chloride, or whatever, from the pool or any other assets or actuator. and we are connected below the PLC, and it's unidirectable, unhackable. We have their isolator that nothing can come from the right-hand side and go to the left-hand side. Then, of course, we sample it in our high rate and calculating everything. And then the alarms, the information can be sent out as per the customer requirements, whether it's on-prem, private cloud, public cloud. There's no risk. And the important thing that you have high value information. And of course, we use German products to be our hardware. Today, we are working with Phoenix Contact from Germany, and we also have installation with them in Germany. So everything is German. So this is what we do. Very simple to connect, very quick to connect, out of band, and you have visibility on a real time what's going on and what anomalies are in the process. So if we talk about, and I'm giving an example, of course, of water companies. So if you talk about multiple site architectures that we have, like Mr. Lacker, they had the SOC, as he mentioned. So in the SOC, they connected multiple water companies to the SOC. So what is the value here? First of all, Mr. Lacker, as being responsible for the entire water in Israel, can see if there is a coordinate or complete attack like the Iranian tried to do on the water. So immediately you can see in the SOC if something is local or something is coordinated like happened. The second thing, as a regulator or as a ministry, it does not impose any risk on the water company. You don't need to open a VPN. You don't need to have a double authentication, integration, or things like that. You come, you connect. At this case, and I don't know all cases, probably to the most critical thing, which is the public health, to the chloride mixture or the wastewater. And Mr. Lacker have all the alarms relevant if there is a major issue attacking Israel. And of course, the local water company have the same pictures. And of course, the SOC service can be applied everywhere as VKU or any other company that have multiple sites look at it the same. So last but not least, so the idea is that we really give our customers the assurance, or you guys as water company, the assurance that to your board members or to your customers that you have the ability to scan all layers against cyber attack. So really, if we're talking about water companies and the complexity that you guys are challenging and the needs you need, so there's no need really for in-house cyber expertise because we invested a lot of the alarms being explanatory. Also because we are using a lot of artificial machine learning, we have a very low false positive rates, and we can share numbers with you. So this is also important. And when it's alarm, probably it's a real alarm. Zero integration with network or control system. I mean, Danny knows it, Mr. Lacker knows it exactly. And even he gave us a mission until the year end to have few more water companies. And we can do it very correctly because you come, 2 hours installation, and the systems start working. And again, no integration, no headache, real value immediately. As I said, robust and out of band, which is important. So no cyber attack can influence your OT network via us. And as I said, we know everything immediately about any cyber attack. And the installation and deploy is easy and quite affordable to anyone. Thank you for listening, and if you need anything, everything is with Simon hands, but I'm always available for additional presentation, discussion, proof of concept, and so on. Thank you.
Wonderful. Thank you very much, Amir. It's a pleasure having you, and this is, of course, a very interesting topic, and also a lot of research is done on it in Germany at the moment, as I heard, for example, from Berlin. Yeah, thank you for being here, and let's see how to pick this up. And I'm looking forward to further discussions in the future. And let me now introduce the next company, Realitech, and Ran Kedem is going to present. Ran, we are very delighted to have you, and we had a very interesting discussion in preparation of today's event, and I'm very happy that you're going to present today. So please, the floor is yours. You're still muted. Can you please unmute?
Okay.
Wonderful. Now we can hear you.
Just a minute. Okay. Thank you very much, Simon. I'm glad to be part of this conference and to be part of the very interesting technologies that have shown today. And I will present Realitech, a holistic solution for digital transformation in water network. And actually it's based on IoT and cloud computing solution or technology. And it also can be considered as a new generation of SCADA, but as you'll see, it's much more than just a SCADA. Before going into the technology, a little bit about the need, and it's based on market survey that was made this year among 500 water executive and CEOs and related to digital transformation challenges. And two of the main challenges that were presented was related to data, the easiest of access to data. And the second one was generally about challenges of IoT. And then it's even more complicated because they have a budget constraint, they have a lack of, or let's say, a difficulty with the complexity of the technology, and of course, the security issue. And that's exactly what Realitech is trying to provide, something which is smart but simple, affordable, and highly secured. And more than we are afraid from the hackers, we're afraid from Mr. Danny Lacker and his team, because they are sitting on us and supervising all the time. So security is a huge issue, especially in Israel, but all over the world. And now a few words about Reali. We're established in 2008. We really were pioneers in IoT and cloud computing. And as I said, we developed an holistic solution that is mainly focused on water and sanitation, but you can find it in many other applications related to environment and smart city applications. Today we are proven technology and installed in more than 40 countries all over the world with large global clients, including, of course, in Europe, as you can see here, and Germany, of course. And this is only one project. All of those sites are related to one project in Europe. You see it's a cross-country project, but again, we have a lot of experience working worldwide. What is the difference between our holistic solution and traditional solution? Traditional solution is based on integration of many devices, software, and technologies provided by different suppliers, different manufacturers, and require a lot of integration and maintenance and are not always interfacing each other. And the idea is Realitech is actually to combine all of those to one single integrated solution, and by that to make it smart, simple, and affordable. By having all of that, dealing the data from handling data from A to Z, from the data acquisition to the remote control, to the analytics, to the SCADA, and up to the cyber, we're making allowing easy access to data in a real time. And again, as we said, this is one of the main issues that utilities are facing. They have a lot of data, but it's not easy to get it, and especially not in a real time. Our system built in only 3 components. The first one is the i6, the hardware, and it's the only thing that you have to install. You install it on the control cabin, on the electric cabin on site, and you can connect any device, controllers, sensors, analyzers from different companies, different protocols, different whatsoever. All of them can be connected to one unit on site. From the unit, it goes through an external modem to the cloud, and then the cloud is the second part of our system, the comp, central online management portal. This is the brain, the soul, and the heart of the system. Everything is done there. And most of the development, most of the wisdom of our system is in the comp. The security, the alert, the remote control, the user interface, everything is done on the comp. And the third part is the user interface, or the SCADA user interface, which is browse-based. So it can be used from any device connected to the internet with no need to install any software or upload any application. Just have to get a username and password, and according to the authorization you have, you can get into the project and do whatever you're allowed to see or remotely control. And of course, we can interface with external software through OPC, API, and other systems. And the main idea is really to be able to connect everything on the network, from a single device to a complete facility like water or wastewater treatment plant, reservoir, whatever you have there, and to build one integrated solution that everything can interface with each other and make it any system there is to a smart system, and to do it in an affordable and simple way. Now I will try to show some of the capabilities of the system through case studies or dashboards and screens from different kinds of case studies. The first one is project water network, rural water network. Actually, it's water and sewage in the northwest of Israel. And actually what you can see here, that all the sites which are connected to the system can be seen on screen, but you can see a real-time asset health of the different sites. So you can see if there is alert, if everything is okay, or if there is some kind of communication problem. So in one site, you can know in a real time the situation of the system. Of course, by clicking on one of the sites, you can drill in and see what the problem is. But not only that, the system can act also as a hub. In this case, it's city of Carmiel. By the way, this is not a map, it's a satellite image, but you can see exactly the same. You can see the health status of some of the sites, but you also can see that there is 15 events here. This is because in this city, there is a huge project of leak detection system, fixed leak detection system, and the high-level management wanted to know in a real time what is going on in the system. So we connected to the leak detection system. We got from them the real-time information of the active leaks, and we can calculate it and show this dashboard for the high-level management, so they can know in every minute how much leaks they have from each category and how much it is money, how it costs them by day, per week, whatsoever, and they can see how it looks along the months and so on, and how they stand in compared to the average or to the target or whatsoever. So we can also not only interface with other software, but also to take data and to calculate it and to present it in a way that will help utilities to improve their management. There's also other calculation. Actually, in our system, you can put actual formulas as you need in order to calculate the data in real time and get information that will help you, again, in increasing the efficiency of the system. You can, of course, calculate, this is data, that raw data, but you also can calculate statistical information. Here, for example, it's another stage that you calculate the accumulated amount of water in all the reservoir, the average consumption, and by that you can know for how much time you have water if there will be some kind of crisis. Here, for example, you can see the fault that you have fault event that you have, open event, and how it is compared to the average, and how long it takes to fix it, again, compared to the average. And here you have energy consumption. So you can get different kind of calculation and give different kind of data in a real time in the system. You don't have to take it for external system and then put it in the system to get data that will help you improve the operation of the system. You can share data between different sites. For example, here you have a reservoir that you can see the level of the water. When it comes to the maximum, a pump in another site starts working. When it goes down, it stops working. when it goes up again, and other pumps start working and so on. So you can learn about the relation between two sides, to learn about the efficiency of the pumps and so on. And of course, you can make them work directly with each other in cases it's needed. You can build any kind of BI screens, dashboards, whatever is needed. This is a project in, I think, in the Bahamas of wastewater treatment plant done by Fluence, I think, another Israeli interesting company. Of course, in many utilities, there are some kind of existing software. Sometimes it's all SCADA, centralized or local. In most cases in Israel, there was already some kind of software used. And the advantage of our system, it can work in parallel to others. So you don't have to replace. And when you're doing upgrade or adding our system, you can continue to use the old system as long as you can, but you can connect new sites or upgrade new sites, some of the sites to our system, and work in parallel in a way that we will transfer data to the old system. So those who still using the old system will be able to use it, and new user will be able to use our system. Of course, then you can update the screens and make it more modern or whatsoever. But working in parallel and doing the upgrade of the system stage by stage is very common with our system. Last but not least, we cannot without COVID-19. We know that during COVID-19, a lot of remote work has to be done. And actually, we understand, most of the new organizations understand that it will not come back to what it was. And this is another survey that have done that almost 70% of the business today are investing in remote work technology. And actually our system is already built for this. It's very highly secured. It's very simple to work from anywhere. You don't have to invest in buying any equipment to the user whatsoever. And you can do it from anywhere, anytime in a highly secured way and safe and with high integrity. That's all. I hope I could present the interests of our system and its capabilities, and I'll be happy to answer questions and whatsoever is needed. Thank you very much.
Thank you, Ran. Thank you, Ran. It's also great to see how much traction you have in Germany already. Maybe we can talk about this a little bit in the final discussion. In order to get there, we are looking forward to our last presenter now, Jonathan from Takadu. Happy to have you, and looking forward to your presentation. And to our audience, if you would like to say something about the challenges you are having currently in your institutions, in your municipal company, please feel free to do so. Raise your hand in the end, and we'll be happy to listen. And having said this, please, Jonathan, we're looking forward to your presentation.
Hi, Simon. Thank you very much, and thank you again for having us here. I think it's not our first collaboration with the Trade Mission and the Israeli Export Institute. We had some very positive collaborations in the past. It's the first one with Germany, and I hope we have the same success with you and with in the Germany market. Okay, so first of all, what is Takadu? Takadu is a central event management system for the distribution water industry. We had, I think we had all the sides of the rainbow in terms of the industry. We had the stormwater and the wastewater, and also Ran talked about the water distribution as well. But we are dedicated to the water distribution network part of the water industry. And basically a central event management system, we're a cloud solution which gathers and brings all the information into a cloud platform, a artificial intelligence analytical platform. And then we're able to analyze the information and provide a smart and adaptive way to show events that are happening on your network. So first of all, before we dive into the tech and how it looks and what it does into the specifics, I'm going to talk about the challenges that water distribution utilities have. And the first and foremost, what actually everybody is talking about is the physical water loss and the apparent losses, basically the RWs. I think 95, 98% of the customers I'm talking to, everybody is focused on non-revenue water and how to reduce the non-revenue water and how to deal with water loss. But we in Takadu, we are seeing all the other challenges that most of them are obscure from the eyes and are more easily neglected. And I think the first one, which is data quality and quantity, all the presenters here before me, all those great companies before me, everybody was talking about data. Now, it's not a secret that data is the new oil of the 21st century. And everything will be owned. And everything that we have already, which is a huge data abundance, is going to be more and more an issue as technology advances all the time. But we have a problem here is how do we maintain that data quality, and how do we actually being effective with all that data we have, that data tsunami in some ways. Now, another challenge, of course, is the operational efficiency. How are we able to achieve more tasks, more events, more things to do with less input in man hours or in costly processes to be able to do so? A third part is the customer satisfaction. Now, it's kind of funny because no customer, no consumer in the water industry is able to choose their provider. We're locked to the providers that we're given by the residential area that we are, or the industrial, it doesn't matter. But again, customer satisfaction is a big factor. How do we reduce downtime to the consumers? How do we provide that high quality water that we're producing, and making sure that the customers at the end are receiving what we're promising them? So we're not going to get complaints. And like everybody knows with Murphy's Law, the first pipe break you have is always in the mayor's street, and it has a big PR issue as well. The last issue is knowledge retention. And I think that every time we are speaking to industry professionals, you always find those 20, 25 years and above experienced engineers or highly capable technicians within the utilities. Now, these key personnel, they know almost every nut and bolt, every pipe, every bushing and every spacer in the system. When something happens, everybody goes to them and speaks, all right, what we do, how to fix, and what are and what is the process to do so. But the problem is that as life proceeds, those key personnel, they will want to advance in their roles. They will switch companies or even reach the age of retirement, and they will just leave the company. Now there is a big void, a big gap, that all their accumulated knowledge is going to disappear because the training time and the uptime and the professionalism required to train a new replacement takes a lot of time and effort. All right, so basically what is Takadu? As I said, we are an analytical system. We're an artificial intelligence-based system, and we're connecting to the data sources that are already available and viable into the network. So we're not dealing with any hardware or any hardware supplies into the network, or just offering strictly software solution. And we're getting the data, our data, mainly from the SCADA system. It could be any SCADA system in the market. It could be a very high-tech SCADA system like RUN as presented to us. It could be the oldest SCADA system in the country, in the market. It doesn't really matter to us because we're just getting the raw information, the raw data of flow and pressure from the SCADA system. We have also the GIS information that we're getting that can give us an additional benefit as an integration to the system. Every IoT sensor in the water distribution network is always welcome and is a positive addition to the information pool. Let's say something like acoustic loggers or anything like that, which is in more advanced sensors and monitors on the network. And we have our other IT systems like the work order systems, asset management, or even customer call centers. Once we have all that information in hand, we're actually creating this nice picture that happens here. You have all the other systems on the back on the wall. Every system here has its a very high importance and its high important role in its operational side. But the monitor in front of this guy's eye, this is the Takadu event management. And what it does, it actually aggregates everything into his eyes. It prioritizes it, it automizes everything, it detects the work for him. And now all he has to do is to manage the event lifecycle by making sure the steps are taken, it's being transferred from one professional to the other. And by the end of time, they're reducing the time it takes them to fix that event. Now I'm speaking over on events, and it's quite a general marker, but events could be every type of thing that happens on your network. It could be leaks and bursts and hidden leaks, which are most important. It could be PRV failures or meter problems, data acquisition issues, data telemetry, water quality issues. Everything that you have the data for it, that is, you have the device to generate the data, then you have the capability of showing the importance and monitoring it in real time. So basically how it works and how it looks. First of all, we're working in a DMA structure, utilities only. We have to have those DMAs, the inlets and the outlets, measured in both flow and the pressure. And of course, we need to have all the levels of all the tanks and water towers and reservoirs inside the DMA if they have those. All that information is going through the data, through the SCADA data, the meters and the sensors is being transferred to our cloud computing center. And then our Takadu algorithms do some data cleansing. We're able to do some smart filling for data gaps, meaning if we have some minor data missing, the system is able to overcome and to still build the predictions, which are the key here. The biggest difference when we're talking about an analytical system like Takadu to traditional operational system in the market is the difference between working by patterns and predictions and by working by thresholds. Takadu doesn't work by thresholds at all. We're always working on 24/7 reliable data and by usage patterns. The patterns are actually built into the predictions, and you have two types of predictions. We have the historic prediction. What is the water consumption yesterday, the day before? How was it in Christmas, between the different seasons, the different climate, and of course the holidays, and of course how can we negate in COVID lockdown times, and how the water consumption has been done historically. But we have another prediction type to increase the capabilities of monitoring, which is the network predictions. And here we are comparing a similar behaving DMAs, similarly behaving in the both types of the population there, comparing residential to residential. And of course, by having a similar pattern of usage in their historic prediction. When we have those two predictions, then we're able to draw those graph bars here, and each event that the system detects is always compared to those predictions to verify if we're talking about a real issue or we're talking about a false negative. In this picture here below on the left side of the screen, it's actually a leak event, which I have to highlight. The blue bar here, you can see this is the current consumption of water, and the green bar below it, that's the historic predicted consumption. The gap between those two bars, this is the anomaly in the pattern, and this is what signifies and shows us there is an active leak in this DMA. We're able to measure the magnitude, the severity, and the duration of the leak only by knowing the data, which is constantly flowing into our system. All right, this we're going to talk so we can go directly through. All right, so Takadu is a very, very robust system in terms of its capabilities and events and the features it has, but still we're talking about a very, very quick uptime For a project, we're talking about 6 to 8 weeks to go completely live after training, after the control room of the utility is fully capable of using this system and start saving in water and in money. I did select one case study, and I only one because we're so short on time. So we have this one. This case actually happened with our customer in Australia called Is Water. It's one of the bigger utilities there. And they had a very big leak, actually pipe burst of 1.2 megaliters per day. We're talking about roughly 14 liters per second, give or take. And you can see that the patterns below the predictions and the current consumption, as I explained in the previous picture, you can see the anomaly between them, and it grows. But the question remains, if you're having such a significant leak, how come nobody have noticed it and been able to see it under the conventional systems, or even having such a big burst? How come we didn't have traces in visual traces? So basically, if you look at the bottom part of the picture, that small highlighted area, this is where the fix has been done. This is where the break was happened. But all the water that was coming out of this break was going down into the Bay Area. Now, because of that unique situation, we are talking about a burst that haven't been recognized by any other system. We haven't seen any other complaints by the customers. And actually, the amount of water I was speaking of, it's enough to fill out an Olympic-sized pool within 2 days only. So we're talking about a vast amount of water. If we're calculating it for annually based loss, which is the average leak detection time it takes to happen with normal detection services, we're talking about a $1 million water leak happening here. So one slide before we are ending here, I got some success stories from clients. I think of the most older clients we have, both are from Australia. We have one, Unity Water. Making short, long story short, we have saved more than $33 million over the 7 years they've implemented Takadu. 22 million are in water loss, and 11 million are only in operational improvements they've been able to give. And the second example I have here is from Queensland Urban Utilities, which they have saved from 2013. They've started using the system more than 6,400 megaliters of water, which are equating for $19 million. One other thing about us, we're 10 years in the market.
Jonathan, yes. Unfortunately, we are short on time. Say some last sentence. I'm very sorry.
It's all right. No problem. Again, thank you for having us. If you have any questions, please pop them on the Q&A section. Thank you very much.
Yeah, so if there are any questions, please raise your hand. So we are very happy you all stayed with us, and nearly all audience also stayed with us, which is highly appreciated. And I think there is a lot of interest or potential for the German market, and we heard a lot about traction of Israeli companies in Germany already. And so when it comes to cybersecurity, also Dani Lacker offered us he will be happy to talk. And so to the audience, if some of you want to share your impressions or what you're currently working on, please feel free to raise your hand. And otherwise, maybe you can quickly say something, and we make a short round of what kind of partners you're working together with. From Kandu, for example, we heard there is a lot of research going on with institutions, and maybe Ran, you can say something on with what kind of companies you are working in Germany, what type of companies are there, and one sentence about your experience.
Okay. By the way, we have quite a lot, as you've seen, quite a lot of installation in Germany, but most of them were not done directly. We worked with several local companies. By the way, we started almost 10 years ago with electrical vehicle charging point with some kind of subsidiary of Volkswagen. But now we are dealing more mainly with industrial application, water quality, controlling water quality in the production process by injecting chemicals to the process to keep the pH. We are doing it with a global chemical company called Solenis that is located in Germany, also in other places in Europe and so on. So actually our system is embedded in their dosing unit, and by that they can control all the supply around Europe from one office, also to control the chemicals, but also to control the supply chain, because they know the chemical storage in each one of their users or clients around the world, and help them to make it more efficient.
Great, thank you. We have one question from the Q&A section. I will read it out aloud to all companies. How does the importance of the German and European market compare to the North American market and to the emerging Asian markets, China and India, for your company? Is Europe a challenge due to its fragmentation? Who would like to start here?
I can give it a shot if you want, or Amir, if you can take the stage. So personally, for us in Takadu, actually the North American market, I mean the American market, not the Canadian, is not such a good market for us, because although it's very big and there are a multitude of utilities there, they're not quite as advanced as other countries, and their infrastructure is very, very old. So for us, they're not a great opportunity. The German market is a bit fragmented, and I know there's hesitance in using cloud solutions in the German market, at least in the smaller municipalities and utilities. Basically, the European market, the fragmentation is not a big issue for us. And the developing countries, emerging markets like China and India, I mean, China is great and it's a huge opportunity. India is a bit more problematic. Again, due to digital advancements they have. So this is something that on our side is what we see.
Amir, you also are working on an answer, I see. Maybe you can share some words.
Yes. So instead of writing, I will say, first of all, we have two major investors, both European. One is Phoenix Contacts, is a German company. And the other one is PureTerra, which is a company, a Dutch company, but focused mainly on water companies. So we are very geared to the water industry, water waste, and so on. Our investors are there, and this is where we focus. We see Europe as the top market for us for multiple reasons. I think one of the main reasons due to the cyber attack, the regulations in EU and is much more towards really building something affordable and something logical, rather than in the US. It's way in almost close to the moon what they asking from the regulators. So I do see us close to the European market. We are about to open an office in Europe. Regarding Asia and India, it's a totally different market, and it's too far away from us, not physically, neither from our experience, but understanding where we can do real business. So I don't see Europe fragmented. I mean, might be more fragmented in terms of the need to build the sales force and the business on the ground, but I do see a lot of correlation from the cyber need, the cyber attack, and I know that the organizations within Europe share a lot of good information about cyber issues. So for us, Europe is the key.
Great. Thank you very much. I don't know if we have taken enough pictures, Esther. Yeah, all right. Otherwise, I would have said we do a group picture in the end, as we would have done. So thank you very much.
Pascal will open the camera. We can do that as well.
If Pascal opens the camera. Yeah, here we are. So we take one group
so
picture.
everybody says cheese. How do you say cheese in German?
We also say cheese, I think. All right. So thank you very much also to the audience. We are looking forward to be in touch. You're getting the follow-up email by tomorrow with all the presentations and also the recording. So we have this as a good material we can also share, and you can also share internally in your institution and companies. So, and we are looking forward to be in touch. Have a nice afternoon. Have a nice weekend to the Israelis already, and looking forward to the next event in this section. All right. Goodbye.
Thank you very much. Bye-bye.
Thank you very much. Goodbye.
Thank you very much.
Bye-bye.
Thank you very much.